In this video, we're going to talk about higher order partial derivatives. So, if you're not comfortable with the first order partial derivatives, the basics of partial derivatives, I've actually made a video about that and I'll link that here for you guys to go take a look at before taking a look at this video. But in the meantime, we're going to go ahead and proceed. So, suppose that you have a function called z, which equals f at xy. You have what are called higher order You can have what are called higher order partial derivatives. So for example, in this case, we're going to take the derivative twice. So as you can see here, we're going to go del squared z by del x squared. So what this means is that we're going to take the partial derivative of z with respect to x, and we're going to do it twice. And the same thing for y too. Now, on the other hand, we can also have what are called mixed partial derivatives. So what that means is we take the partial derivative of z with respect to y. So there should be a z here. Excuse me. Okay, that should be a z. You can take the partial derivative of z with respect to y, and then take the derivative of that function with respect to x, the partial derivative of that function with respect to x. You can also do it the other way as well, and it'll equal the exact same thing. So first you can take the partial derivative of z with respect to x, and then you can take the partial derivative of that result with respect to y, and again you're going to get the exact same answer. So to demonstrate that, we're going to do a few examples here. So we're going to find some higher order partial derivatives, in this case second order partial derivatives. So what we're going to do is we're going to get del squared z by del x squared, del squared z by del y squared, and then we're going to do this. Okay, so del squared z by del x del y, and then basically the same thing but in a reverse order. And we're going to do it for this function here. So for the function z equals f at xy, which equals 2y squared minus 5xy minus 3x squared. So let's go ahead and do that right now. So let's start with the first one here. So we're going to be taking the partial derivative of z with respect to x twice. We're going to differentiate with respect to x twice. So we're going to write our d squared z by dx is equal to, okay, d, or that should be a squared there, x, and then z by del x. And what this will give us is this. So it'll be the derivative, the partial derivative with respect to x of, let's do the first partial derivative here. With respect to x, so this goes to 0. So this will be 0. And then this becomes 5y. So we differentiate with respect to x. The y and the 5 are constants. So that will be minus 5y minus 6x. 6x. So as you can see here, we're going to do another partial derivative with respect to x. So let's do that right now. So this goes to 0. This is a constant, so this becomes 0. Okay? The 5y is a constant. And then minus the derivative of 6x is just 6. And so that will give us negative 6. Now how about we do the same thing but with respect to y both times? So del squared z by del x, or excuse me, del y. Yes, that's this one right here. Del x. Oh. Old habits. Del y and del z. This should be squared. Del z by del y, which is equal to derivative with respect to the partial derivative with respect to y of this. So let's differentiate this with respect to y, and that'll give us 4y minus, okay, the x is now treated as a constant, so when we reduce this, the 5 and the x become constants, so when we take the derivative of that, it just becomes 5x. And then, since there's no y term here, this just goes to 0 because the 3 and the x squared are constants. So that goes to 0. And now we're going to take the partial derivative of this again with respect to y. So let's go ahead and do that. So 4y, it just reduces to 4. The 5x, the negative 5x is a constant. So that goes to 0, and then 0, and so our answer just becomes 4. Now let's try this one right here. So the partial derivative of z, let me scroll down a little bit here, create some space. The partial derivative of z with respect to x and y. So that'll be dx, or del x I should say, and del y. So in the first instance, what we're going to do is we're going to differentiate this function with respect to y first. Okay, so we're going to go dz by dy. So that'll be, and so if we differentiate this with respect to y, we get 4y minus, excuse me, 5x minus 0, just like before, just like this instance here. But now the only difference between this one is we're now on the second attempt we're going to differentiate with respect to x. So let's do that now. So when we differentiate this function here with respect to x, we'll notice that this 4y is a constant, so it goes to 0, get negative 5, and 0, which just gives us negative 5. Now what if we were to do it the other way around? So we're going to differentiate with respect to x first, and then differentiate with respect to y. What would that look like? So I'm going to scroll down just a tad bit, or scroll up just a tad bit more. Okay, so we get this function here. So we have del squared z by del y del x, which is equal to del by del y times, or sorry, not times, but the derivative of del z by del x. And so what would that look like? Well, I'm going to differentiate with respect to x first. We're going to take dz, the partial derivative of z, with respect to x first. With respect to x first. And that will give us 0, because this 2y is a constant, and then we're going to go minus 5y minus 6x. And now we're going to take the partial derivative of this new expression with respect to y. And look what we get. So the 0 remains 0. This goes to 5. And now since the 6x is a constant, it goes to 0. And so what we're left with is negative 5. And as you can see here, that these two answers are equal. Okay, and if we go back up here, that's what this tells us here. So it doesn't matter which order in which you differentiate, you're going to get the same answer. So that is the partial derivative, or I should say an intro to higher order partial derivatives. I just want to make a note of one more thing too. This can even extend further to other things as well. So you can have things like del cubed z by del x cubed, or you can have something like del cubed z by del x squared y. So this is a mixed partial derivative, and so it'll look kind of like this: del by del x times del squared z by del x y. And it can extend even further than that. You can have things like del, you can do a fourth order partial derivative. So del z by del y to the 4, etc. Okay, so it goes on and on and on. So yeah, that is higher order partial derivatives. And in the next video, we're going to talk about the chain rule for partial derivatives and how to get the total derivative of a function.